Hello everyone, welcome back to Chemistry Travels. It's been so long that I uploaded any video and finally I've come up with one. Today's video will be on the topic of carbohydrates. Carbohydrates is quite a simple topic, and though it does not carry that much weightage for our entrances, it at least some 2-3 mark based questions definitely come from this topic. And since every mark count for our exams, it is always best that we don't leave out this topic since it's an easy topic. You can easily catch up with the topic. And under this topic, there are so many concepts that have to be dealt with. So it's going to be a vast topic. So this upcoming videos will also be on the same topic, carbohydrates, and we'll be looking into different subtopics such as definition, classification, the various configuration for various carbohydrates, about epimers, then various chain lengthening and shortening methods, chemical methods such as the Kleine-Fischer synthesis, Wolfram's method, rough degradation method, wall degradation method. And we will also be dealing with some of the most important carbohydrates such as glucose and fructose, how you can convert from glucose to fructose and vice versa, then about sucrose, starch, cellulose, and so on. And within these topics, further we will be dealing with many important subtopics such as the mutarotation, ozone formation, Harvard structure, pyranosform, furinosform, and many more. So without wasting any time, let us move on to the concepts. So in this first video on carbohydrates, we'll be dealing just with the basics, just an introduction to carbohydrates, that is just its definition and some classification with their examples. So to talk about the definition, what are carbohydrates? So, an older definition to carbohydrates, earlier it was considered that carbohydrates are simply hydrates of carbon. That is, they just have carbon, hydrogen, and oxygen. And also, this hydrogen and oxygen are in a ratio that is same as that of water, that is 2:1. And they can be represented by the general formula CxH2O Y times. This was the definition that was given to carbohydrates. But the problem arises that there are certain compounds such as our formaldehyde or acetaldehyde. These also follow the same general formula of CxH2O Y times. But their chemical behavior is different from that of carbohydrates. So this definition does not hold. Formaldehyde, acetic acid and all are not carbohydrates as we all know. But they have the same general formula. So that general formula cannot be a definition to carbohydrates. Now, another set of compounds like our rhamnose or rhamnohexose, they are certain compounds whose chemical behavior is same as that of carbohydrates. They have the same behavior, but they have different formula. That is CxH2O, that H hydrogen oxygen ratio is not 2:1 like the case of water. So these two definitions are not matching for all compounds. All compounds that follow this definition may not be carbohydrates. So there has been a shift in the definition and we can consider carbohydrates. We can give a new definition to carbohydrates as simply they are polyhydroxyaldehydic or ketonic compounds. They are those compounds having hydroxy groups, several number of OH groups as well as aldehydic group and ketonic group. Or they can also be a compound that on hydrolysis give rise to this polyhydroxyaldehyde or ketones. They can either be a polyhydroxyaldehyde or ketone, or they can be any compound that furnish this polyhydroxyaldehydes or ketones upon hydrolysis. So this can be considered as a definition for carbohydrates. Now to look at the classification of carbohydrates, there's several classifications that can be given to carbohydrates. First classification can be based on hydrolysis product. As we saw in the definition, carbohydrates are those compounds that furnish polyhydroxyaldehydes or ketones on hydrolysis. So the concept of hydrolysis comes in. So based on the product that is obtained upon hydrolysis, a carbohydrate can be classified as monosaccharide, oligosaccharide, or polysaccharides. And polysaccharides can further be classified into homopolysaccharide or heteropolysaccharides. Okay, and now based on the functional group that are present, carbohydrates can be aldehydes or ketones. So based on the functional groups present, we can classify them into aldose or ketose. Again, these aldoses and ketoses further can be broken down into four different parts, which is a triose, a tetrose, a pentose, and or hexose, depending upon the number of carbon atoms. And another classification based on their physical and chemical properties is sugars and non-sugars. So this is an overall classification of carbohydrates into several groups based on various factors. Now we'll be looking into each of them separately, dealing with each of them separately with examples. So this is the first set of classification that we told about based on the product we obtain upon hydrolysis, that is a monosaccharide, oligosaccharide or a polysaccharide. Now monosaccharides are those carbohydrates which cannot be further hydrolyzed. They cannot be further hydrolyzed. Like the case of glucose or fructose, for example. They can't be further broken down into polyhydroxyaldehydes or ketones. They are the basic units. They are monosaccharides. Now, coming to oligosaccharides, they are those carbohydrates that on hydrolysis give rise to 2 to 9 monosaccharides. Lower number of monosaccharides they will produce. 2 to 9 monosaccharides can be obtained from an oligosaccharide upon hydrolysis. Like the case of sucrose. Sucrose, when you hydrolyze sucrose, acid hydrolysis will give rise to 2 units of monosaccharides, which is a glucose and a fructose. So these oligosaccharides can either be a disaccharide, a trisaccharide, tetrasaccharide, like depending upon how many number of monosaccharide units it is giving. Sucrose is a disaccharide. It's an oligosaccharide which is disaccharide because it gives rise to 2 monosaccharide units, that is glucose and fructose. Now, the third set of classification is the polysaccharides. Polysaccharides are the ones that give rise to large number of monosaccharides upon hydrolysis. And these polysaccharides can further be classified into homopolysaccharide or heteropolysaccharide. Homopolysaccharides are the ones that give rise to one type of monosaccharide. There will be n number of that one particular monosaccharide, like in the case of starch and cellulose. But heteropolysaccharide will be one that give rise to large number of different monosaccharides. More than one monosaccharide will be formed as the product. An example for that is the alpha globulin. Clear? The next set of classification is based on the functional group that is present. If an aldehydic group, if it's a polyhydroxyaldehyde, then that carbohydrate can be termed as an aldose. And if it is a polyhydroxy ketone, then the carbohydrate can be termed as a ketose. Aldoses and ketoses again are further subdivided based on the number of carbon atoms that are present. Right. So based on the number of carbon atoms, if they can be classified into aldotriose. This aldose group are classified into aldotriose, aldotetrose, aldopentose and aldohexose depending upon whether they have 3, 4, 5 or 6 carbon atoms respectively. An example for each of them are an aldotriose like glyceraldehyde, which is the most basic one. Then erythrose and threose come under aldotetrose. Arabinose, ribose and xylose are examples for aldopentose, and famous glucose, then mannose, galactose, these are all aldohexose. Glucose and all we know it is C6H12O6, C6 times. So 6 carbon atoms. So they are aldohexose. Now the same classification can be given to the ketose group also. 3, 4, 5, 6 carbon atoms will give rise to ketotriose, ketotetrose, ketopentose and ketohexose respectively. And examples include dihydroxyacetone, erythrulose, ribulose, cellulose, fructose and sorbose respectively. Right, for each of it. These are some of the examples, and this is the classification based on the functional group that is present and also based on the number of carbon atoms that are present in the carbohydrate chain. And the final classification is based on the properties in the sugars and non-sugars. Sugars are the ones that are sweet, crystalline solids, and they're water soluble. Those carbohydrates which are sweet, crystalline, and water soluble can be termed as sugars, like our glucose, fructose, and sucrose. And when you come to non-sugars, they are the exact opposite. They are tasteless, they're amorphous solids, they're amorphous, and they're water insoluble, like the starch and cellulose. We know that they're water insoluble, they're tasteless, and they are amorphous solids. Usually, the monosaccharide groups are called sugars, and the polysaccharide groups are non-sugars. So, these are the different classifications of carbohydrates, and that's enough for part 1 of carbohydrates. This is a basic introduction to carbohydrates. So, I hope you understood what has been told in this video. This was just the basic introduction to the topic. So, see you with another video dealing with the remaining topics of carbohydrates. So, that's it for today. Thank you so much.